All right, we are working in these notes. So 1-9 graphing calculator investigation. It looks like this on your front page. And if I scroll down, you can see that we're going to be doing graphs. So you need your graphing calculator out and your paper, and I am going to the graphing calculator. Now, you guys can tell me with this, let me see if I can change the view. I think that's the best we're going to do. So I am showing you my calculator screen here. It will put up the keys up here. And since my screen's a little different, it's not as wide as it could be. So first thing I need you guys to do is just clear anything out that's in there. You don't have to do that, but let's just start fresh. The other thing I need you to do, because I don't know who used your calculator last and it was reset, go to the second button, click on second, and go up to where it says y equals. If we're doing the second button, we're doing the stat plot. And what I want to see that all your plots say off, and just to play it safe, we're going to tell it to override all the plots turn off. So I'm going to select option 4. Did we all get there? Where's your cow? So now when you're up here and it says plots off, you haven't done anything yet. I need you to now hit enter. So hit enter and it will tell you done. So your calculator, you're giving it a command and you have to say, I want you to do this, and then it will tell you done. Are we good? Okay. The problem is if the plots were on, it's going to have different graphs and throw things off. Now, the next thing I want to make sure we do is go into the middle zoom. See this right here, middle key says zoom, and there's lots of different things to do. Like once you have a graph, you can zoom in or zoom out. We're going to do option 6, which is zoom standard. And what that does, and this is on your notes, it sets your screen to a -10 to 10 window for X and Y. So just hit option 6, or you can arrow down. I prefer just hitting in the 6. You can arrow down and hit enter. And I already have a graph on here. Let me clear that. And your graph should look like this. And it goes from -10 to +10, -10 to +10. Okay. Now, again, we can change the look of the graph, but for today, we want to just keep that 10, -10 to 10 graph. Everyone good there? All right. So we're flipping over your notes, and you can quickly read those directions. Take a minute, read those directions. Okay, now that we've read the directions, we are using the calculator to help us. In class the other day, we used the XY charts, right? Like we weren't sure how to graph, so we made XY charts, we put it in. So pay attention to the keys you're gonna hit. First thing, anytime you need to get out of here, sometimes you can get clear and get back to your home screen, but if you really get stuck or locked in somewhere, you can hit second and the mode key says quit, and that will always take you back to the home screen, okay? So sometimes you can just hit clear, but if you're nervous to hit clear, hit second quit, it brings you back to home. I'm going to clear this, and I'm going to clear the history just to make it cleaner. All right. Now, go to your y equals key. This is where you can put any equation in. All right. Are we all y equals? Now, what's different about these calculators compared to the old ones is called the color edition, because you can see that you have different colors. And we'll talk about these things, but if you arrow over, you can change these options by, clicking up, or by hitting enter, and it changes. You can select the color or like the type of line, etc. We don't need to worry about that, so I'm just going to say okay and get out of there. Get me out. Oh, I changed it to red. Okay. So no big deal. I changed it. Let's go over, and when you go to type this in, here is your X variable key. That is the only variable key you can use. Do you see it right here? So catty corner from second, type in that X. You can't use, you guys can see you have alphabet keys right here. It doesn't recognize the alphabet key as a variable. So if you're using a variable, you're using this X key. To get T or theta or N, you have to change calculator modes. So we will always use X in here. And then we're going to square it. So we're doing the first function. There's your square key. Do you see it right there where I'm circling? There's your square key, and then -7 Make sure you're using your minus key. Look at the difference. Negative key, minus key. Do you see the difference? So you have to be careful using those keys. I can go in and hit my delete key to get rid of that and hit graph. There is my U-shaped curve called a, remember what that was called from Friday? That U-shaped curve? Well, it's called a parabola, okay? How did I know without graphing it that this should be a U-shaped curve? What on the function told me that this should be a U-shaped curve? I'm going to jump back to the notes here. What on the notes told me that this should be a U-shaped curve? This x squared. So on Friday, we went over functions and we looked at them and we named them and things like that. So I need to be able to see, one, the graph, and you're going to do a better graph than I am right here. The graph looked like this U-shaped curve. We'll make it a little bit more accurate, so don't do your graph yet. I need you guys to catch that when there's an x squared, it's going to give me that quadratic function, which is a U-shaped curve. Now, last week we did all the parent functions, and the parent function looked like, well, you could probably do better than me, looked like a U-shaped curve through here. Okay, so we need to figure out how this changed. So let me go back to my calculator and talk about this real quick. First of all, on the calculator, you can go ahead and sketch your graph. So let's look at this. You can count down and see the points, or you can hit this little trace key. See, I hit the trace key and it gave me the ordered pair of 0, -7. Probably easier to see on your calculators than mine. Did you hit the trace key? And then do you see the ordered pair down on the bottom of your screen? So make some tick marks on your graph, sketch that in, make some tick marks on your graph, sketch that in. So that's one way to do it, is to trace and get an estimate of where points are. So do you see how I'm arrowing left and right, and then it's reading me the ordered pairs? Okay, what's a better way to get points off my graph? So we went to y equals, we wrote in the function, we graphed it. Do you see right beside or right above graph it says table? You know how we made the XY charts on Friday? Go to second and hit that graph button to go to the table. Do you see my ordered pairs in here? So now I can just make nice points on my graph at -4, 9, and -3, 2, and -2, 3. I can put a couple points on my graph just like we had our T-chart. There's X, there's Y, and I can sketch a nice accurate graph. Okay, did you follow where I went there? To get to the table, hit second and graph, and that takes you to this table. Now, you might have started at a different place. You might have started at 0. I can just arrow, and it's going to bring me back and forth. All right, is everyone finding that okay? All right, now, graphs don't have to be perfect. It should be a decent sketch with a couple points. I'm going to hit second and that quit button, but I want to go back to y equals, and I want to show you something. Go to your next one. I have to change my color because I screwed up and it was the same color. I'm going to do light blue. Okay. Okay. So if you're here, let's go ahead and type in the parent function, which was x squared. So we have the new function, and then we have that parent function. So as soon as I saw an x squared, I knew I needed that. Now, go ahead and hit graph. What's going to happen? I'm going to have two graphs. So what's nice is I have two different colors. And what's really nice, if I hit trace, look at the top. It tells me which graph I'm on. It says I'm on the first graph, which is x squared -7, and here's a point. If I arrow up, it jumps to the other graph, and now I know that's just my x squared. So if you arrow up and down on trace, you can flip graphs. If you arrow left and right, you'll switch, from side to side and find new points. Okay, so why am I showing you this? Well, if I know what the parent function is and I know how this other graph changed, what changed in my red graph compared to my blue graph? And guys, if you're exploring and doing other problems, I'm really trying to show you this, so please stick with me on this problem. What's the transformation? So the idea is we had a parent function that started where my blue graph is, and then we did something to it and it changed. Okay, so it moved down. It's like it took that vertex that was at 0, 0. Remember how we talked about the origin, how they went through 0, 0? And it moved it down 7 points or 7 units. So that is your transformation. A transformation is the change in the graph. Did it move up, down, left, right? Did it get wider or narrower? So in ours, a basic description, the graph moved down. If you want to be specific, I think that's great. It moved down 7 units. Well, that makes sense because we had a parent function x squared, and then we said x squared minus what? 7. Okay, so that's what we're doing. Now, let's go back to our y equals, and we're going to clear both of those functions out. Just hit clear. And this time, I'm going to type in the next one. Number 2 has the square root of x minus 3. What kind of graph do you think that's going to be? Like, look at your options. Linear, quadratic, cubic, cube root, square, or absolute value. So you're looking at the second problem. What kind of function is this, guys? Okay, so it's going to look something like this. We just don't know where it's going to be. What's the name of the function? Linear, quadratic, cubic, cube root, square root, or absolute value? I mean, it has a square root, so I'm going to say it's a square root function. Now, this is not the graph that I drew. This is just saying this is what it should look like. So after Friday and today, you should be comfortable to say it has a square root in it, so it is a square root function, and this is what it should look like. I just need to figure out where it goes. But you should have the basic idea of everything. Okay, so let me get out of this. Let's put in the parent function. Now, if you're not comfortable with the parent functions, I'm recommending sometime soon you make note cards so you know which is which. So I'm going to put in the parent function first, which is second and your square root sign. So hit the second and then your x squared key. And now I'm just going to put in the x. So that's all I'm doing is a square root of x. That's the parent function. And then I'm going to arrow down. I'm going to do it again with the square root. And this time I'm going to do x, what does it say? Minus 3. Now, do you notice it all stayed underneath the square root sign? If I need to get out of the square root sign, I'm going to hit that little key to get out. So this calculator runs a lot like the multi-views, where it stays underneath the square root sign. If you were using the other little calculators, you would have to have parentheses around it, okay? So pay attention that this should be underneath the square root sign, and then we're going to hit graph. So I did the parent function in red. I did the function we're looking at here, and I'm going to hit graph. So there's 2 graphs. There's the original in red, and what happened to my new one that's in blue? It moved to the right how many units? 3 units. So in your notes, you don't have to sketch the parent function, and you should sketch the new graph. If you want to sketch the parent function, just make note of it. And then just make quick tick marks and give a guess. Now, or not a guess, a good estimate graph. Again, if you want more details, hit second and graph, and that will give you the table. Now, why do I have all these errors here? Why does it say error? And notice I have 2 functions. This is my first function, and this is the parent function, and this is the one we're looking at. Why do I have all these errors? What was our function? What is our function, guys? What is it? It's a square root. So why is there an error by the square root of negative 4? Can I take a square root of a negative? So that's why it's telling you error. So then the first thing I can take a square root of is 0. Now, if you look at the second one, it still says error until I hit what number? 3. Okay, well, let's think about that. That makes sense. If you think about the function, our function was x minus 3. Well, if I plug 3 in there, 3 minus 3 is what? 0. And what's the square root of 0? 0. If I plugged another number in there, like 2. 2 minus 3 is negative 1. Can I take the square root of negative 1? No. So that's why you're getting those errors. So the first and the lowest number that we can have is 3. And then we got the 0.30. Then we get the 0.41. And then you have some other points. So if you arrow down, maybe you find another nice point at 7, 2. So you can use your table to help you get points just like we made XY charts. Okay. Are you ready to do the next one? Can I move on? Are we okay in the calculators? Okay, so let's go through this and hopefully I can make sure we're all clear on this. I'm going to go ahead and go back to y equals, and I'm going to clear both out. All right, are we good with that? The next function on your paper is x to the third minus 2. So without graphing it, it's x to the third minus 2. Do you have an idea of what the graph should look like without graphing it? If not, again, you need to know the name of the function, the parent function, and what the graph should look like. Like I should be able to give you a matching game and you should be able to match up an idea. Just like the other day how you did, I gave you the function and you matched it with the graph and the name, okay? So some of you are going back to your notes. I know we know it's cubic because x to the third is cubic. Now that you've looked back at your notes maybe, do you see what the graph should look like? Okay, now the parent function looks something like that, where these both go out to the right and down to the right. So we need to now graph that and see how this changes. Okay, so now that we know it's cubic because we had x to the third, we have an idea of what the graph should look like. Let's go graph it. All right, let me clear all of this. So again, you want to use this X key right here. And then you have two options. You can do your power key, which is over here. It's different than your other. Do you see your little caret key? You could do that and it pops it up to the power of 3. So it looks like a power of 3. Your other option, when you type X in, you can go to your math key. And you see option 3 is a power of 3. So you could do it either way. You could use your caret key or you could use your math key. All right, that's the parent function. And then let's type in what they gave us, x to the third. And now see how, if I'm not paying attention and I type in this minus 2, where's that minus 2? In the power, should it be up there? Nope. So when you're up here, you need to arrow so you get back down. All right, and then I'm going to say minus 2. So be careful with that. Are we good with our functions? Okay, and then hit graph. So the original for me is in red, goes through the origin, and then the new one, what happened to the new one that I have in blue? It moved down, and we could be specific, it moved down 2 units. Okay. Someone mind getting the door? So now that we know that, you can sketch it. What might help you sketch it? Again, you could hit the trace key, and you arrow up and down to switch graphs, and you arrow left and right. But if you want this, you can hit second graph, and that will give you the tables. Now, you can see that some of these numbers are way off the graph, right? Negative 3 to the third minus 2 is negative 29. So when you do your table, you have to remember, I put the parent function in here first, and the function I want is here second. Okay? So the table is just to sort of help you get some nice points on your graph, sketch in your graph. All right. Now, I want to say, oh, are you comfortable doing the next one on your own? But I don't know that you know how to enter it. So take a second. Look at the next one. What do you think it's going to look like? What kind of function is it called? So I'll give you a second to think about it. So we are moving on to the cube root. I mean, it literally says cube root. So can we all agree that the cube root would be here? Cube root, right there is your index of x plus 3. And then we know that the x to the third look like this. So the cube root is going to look something like this. Now that's the parent function. We need to see what happens here. So we should be comfortable seeing a cube root, knowing what the parent function looks like, and knowing the name of it. All right, let's go to our graphs. And then I'm going back to y equals, and then go to your math key. And you see option 4 is your cube root. So again, math key, and then option 4 is your cube root. Now, if you needed some other root, like a fourth root, you go to option 5. All right, and we are going to type in the parent function of just the cube root of x. And then I'm going to do it again with math, and I'm going to go back to the option 4. I like to just select 4 rather than arrow down and hit enter. It's quicker for me. And use your X key, and then minus, what was it, minus 3 or plus 3? All right, plus 3. Again, you're still underneath the root sign, so if you had something else, you would get out of it and go ahead and hit graph. And there are the two graphs. So a parent function was my first one. Again, if you're unsure, click on trace and it will tell you at the top what function you're looking at. Do you see how that 3 is out front because it says 3x root? That 3 is defining the root. All right, so what happened to our graph, guys? Here are the origin, you know, it's 0, 0, and that's where the graph twists. And it looks like the other one went where? Up, down, left, right. I'm going to go, went left 3 units. All right, if you want to see more specific, go to second table. Remember, this is the parent function, and this is what we changed. This is the cube root of x plus 3. All right, I'm going to let you do number 5 on your own. Give you a couple minutes to do that, and then we'll look at the next one. Okay, so the next one on is going to be linear. Are we all, I mean, why is it linear? Because you have x to the what? First. That makes it linear. So we know we have our line that should go through the origin 0, 0, and we're trying to see what the 4 times x does to it. So you went into your calculator, and you type in the parent function of x, and then the bottom would be 4x. And I like having both because it helps me see what happened. Okay, so yep, I get a line, and this line is steeper. It does look like it rotates. Again, you can hit your trace key. They both have the origin, so it didn't move up, down, left, or right, but it is steeper. So you can use your arrows, move from one graph to the other, or second and table. Okay, so again, pay attention. You know, did you put in the parent function first and then the function? All right, with that in mind, how do I get out of here? If I hit clear, it doesn't do anything. So I'm going to hit second quit. I want to go to y equals, and let's talk about the next one. What is the next function? Number 6, what would be the parent function? What would be the name of it? What is it? Should be absolute value. And the parent function that would match this is y equals the absolute value of x. And the parent function is that v. This is not the right angle of the v. It should be a little wider here. But that's what the parent function, so you guys should be able to look at this and say, it's called absolute value. The parent function is the absolute value of x, and it looks like this V shape. The question is, what's going to happen to this V shape? So here we go with our calculators. Now, to put in the absolute value, you're going to go to that math key. It's not here, but arrow over to number. Did you find it? So again, select math, arrow over to number. Get rid of this. And then the first one says absolute value, so I'm selecting that. And it does look like absolute value keys in here, or the bars. And we're doing the absolute value of x. I'm doing the parent, and I'm going to go back to that math key, over to number, and option 1. And this time I'm going to put in what? X minus 4. And then I can arrow to get out of there. If there was something else like I was adding to it, I'm going to hit graph. There are those V shapes. So again, you want more accurate, you can go to table, but the V didn't go up, down, left, or right. I'm sorry, it didn't go up or down. It went right, what, 4 units? Okay. It didn't change the shape. It's not wider. It's not narrower. Again, second and table can help get you some nice points to get a good sketch. Okay. At this point, are you comfortable to try the next couple on your own? Okay. It is really important that you put things where they belong and you use the parentheses. Next thing I want to remind you of, just real quick, hit second, quit. How do you put a fraction in these? Look up here. Let's talk about how to put a fraction. I think some of you have figured it out. Hit the alpha key, and right beside it is that fraction key. So alpha, and then the variable key. Do you see how the boxes there? And that's how you put a fraction in. Did everyone find the keys? Alpha, and then that, and that's how you can put a fraction in, because you'll need a fraction. Again, please make sure you use parentheses. On a problem like number 11, 11 has a negative sign out front. You have to use the negative sign on the calculator, not the minus sign. Okay, so be careful with that.